All right, so now let's look at graphing one single line. Let's kind of look at the difference in how this plays out. Let's say we had a simple graph as y is equal to x minus 2. Okay, let's graph this linear equation or this function. If I wanted to graph this function, what two components do I look at, or what two components must I go ahead and recognize? Okay, what is negative 2 going to be? Start point, which would be my b, right? And then my slope here is what? 1 over 1. Good. Therefore, now with that being said, let's graph this information. I have a slope of 1 over 1. I have a start point of negative 2. Now, if I want to graph this line, because this is the regular function, I start at negative 2, and my slope tells me to go, is it a positive slope or a negative slope? Positive, right? So it tells me to go which direction? Up to the right. So therefore, I'm going to go up 1 to the right. I'm going to keep following that pattern until I fulfill establishing a consistent and accurate line. Therefore, I'm going to go down. Of course, whether it's dotted or solid doesn't matter at this time, because this is just an equation, not an inequality. So therefore, there is my line. That's graphing a linear equation, which we, again, should be very familiar with. Graphing a linear equation starting at negative 2, your slope being 1 over 1. Therefore, you're going to go up 1 over 1. Up 1 over 1, up 1 over 1. You go down 1 to the left 1, down 1 to the left 1. Now let's take the same problem and let's turn it into an inequality. Let's see if it differs, or when we look at it from an inequality perspective. Let's say that we had this as y is greater than x minus 2. Again, same format. It's still in what form here? Slope-intercept form. That's the form I need to make sure that it's written in, which is slope-intercept form. Again, my slope is going to be what here? 1 over 1. My start point, or my b, is negative 2. The only thing that I have to consider here is what now? What must I consider about my inequality? No. If I'm looking at my inequality and I wanted to graph, what must I consider here now? We just went over the differences and similarities. Yes.
But your line has to be dotted.
Yes. Why is my line dotted here? The sign is not less than, but greater than. It does not contain the what? The equal to sign up underneath. So therefore, again, you're absolutely correct. My line here is going to be dotted, not a solid line. So therefore, I still graph it the same. I'm just going to have a different type of line. I'm going to start here at what? Negative 2. Go up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. I just continue my path until I have, again, an accurate established line here. We've just established that our line here is going to be dotted. So therefore, I do not do a solid line. I just go ahead and dot along my points, indicating that this dotted line means what about this particular line or this particular inequality? It's not part of the solution. That this line, everything on this line, will not be included in the solution. So it would be like an open circle if this was an inequality that we were solving. So now, after we've done that, the next thing that we need to do would be to what? Not just shade, but we have to do what first before we shade? You have to test it, right? I'm going to test the shade. So how do I test the shade? What point did we say we can use? 0, 0. Because my line does not pass through 0, 0, I can use this test point. So therefore, if I'm using my test point of 0, 0 to test the shade, we say that we plug in 0 for x and 0 for y. So therefore, this is going to be 0 is greater than 0 minus 2. What does this become? 0 is greater than negative 2. Is this true? Is 0 greater than negative 2, or is this false? It's true, because 0 is greater than negative 2. So therefore, what do we say about true or false? If it's true, what do we do? We shade the area that our test point is located in. Where would our test point be located? It's going to be located below or above my line? Above. So therefore, if this point is true, then everything above this line is going to be what? It's going to be shaded in, and it represents what? Being what? True. It represents being true. So therefore, I shade everything above this line, because everything above this line, no matter what point I pick above this line, if I plug it into my linear inequality, it's going to come out to be true. So I would shade everything above this line representing my test point and representing that inequality. Is that clear? Yes. Question?